Section 6.6. In the previous sections, we covered the basic graphs for sine, cosine, tan, cotan, secant, cosecant. And here we are going to introduce kind of like more general form of sine, cosine, and tan. What about like if we have more complicated graphs or functions? So we are going to introduce the general case for sine, which starts with y equals a sine omega x minus phi plus b. So this is a Greek letter phi. So for this one, if we start with by dropping the phi out, so that would be wx or omega x. You can say w or omega. Both of them are Greek letters, the omega. So w or omega, this should be bigger than 0. For the entire section, we're going to assume it's always positive. From previous sections, you remember what we found amplitude. That was the absolute value of A. And then we had a period. We found the period here. It was 2 pi over omega. 2 pi over omega. Let's call it capital T. And this period went from, it starts at x equals 0 to 2 pi over omega. So to the up to that period, T. So up to T. So 0 to T. So 0 to 2 pi. That was the period that we did. So for just sine x, we chose it to be 0 to 2 pi. So then what I'm going to do with this, with the one I started with a sine omega x minus phi, we can rewrite this as a sine. Watch what I'm going to do. I'm going to factor omega out. That gives us x minus phi over omega. I hope you can see what I did. So just think about if you distribute back in the w, you're going to get or omega x minus phi. So that will give you the line right above it. So that's a factoring thing. So now if I compare this matches this part, matches this part. You see it? These two, the yellows. So in the function, the original function there, x went from 0 to 2 pi over w, or over omega. So I can apply it to this one to see where is this going to start. So the first one was x equals 0. So this means this thing here equals 0. And this will go, you can set it this way. This will go to x minus phi over w equals the 2 pi over omega, or omega. You can say omega or w. So x equals phi over omega, and then x here, if you add phi over omega to both sides, plus 2 pi over omega. So that would be phi plus 2 pi over omega. So this means the period is going to start, so the period for such a graph, it will go from phi over omega all the way to phi plus 2 pi over omega. So that's for the more general one. So then we can say from the graph of y equals a sine omega x, we can shift it phi over omega units, well, to the right or to the left, up or down. Well, omega units to the right, either is going to be to right or left. To the right if phi is positive, and to the left if phi is negative. This number that we have been using, phi over omega, is called the phase shift. It's called the phase shift. In general, so what we have, in general, we can say in general for the graphs of y equals a sine omega x minus phi and or y equals a cosine omega x minus phi, where phi is bigger than where omega bigger than 0, we have first thing the amplitude. The amplitude is always absolute value of a. The next one is the period. Period is t is 2 pi over absolute value over omega, because omega is positive, so we don't need the absolute value. And the phase shift, three important things. Phase shift is phi over omega. These are the three things that are really important to know for this section. So I'm going to go over one example about graphing, and that's what this section is going to be about. How you find amplitude, period, phase shift, how we graph it. So one example that's going to take a lot of time, step by step, but as soon as you get this example, you're set for this section. So given y equals 4 sine, let's say 3x minus pi. So this function is given. We need to find the amplitude, period, phase shift, let's say, and phase shift. Then graph it. Graph means sketch a graph. Let's start with this. First one is the amplitude. That's the easiest one to find. Amplitude is always the absolute value of the number in the front, which is 4. Phase shift, or the period, what's the period here? 2 pi over omega. Omega in this case is 3. That's the period. So that's t, that's the 2 pi over omega. That's the period, 2 pi over 3. Okay, and what else we have? We need the phase shift. So what's the phase shift? How do you find the phase shift? Let me write that down again. Sine 3x minus pi. We can factor the 3 out. Sine, that would give x minus pi over 3. This number that you see there, the pi over 3, that's the phase shift. So the phase shift is pi over 3. Again, that's phi over omega. Phi over omega. So now we know that the period is 2 pi over 3. So we need to know, where does this start? Where does it start and where does it end? The period for this one. It's just the length of the period is 2 pi over 3. Now, of course, you can start anywhere you like. You can start from 0 to 2 pi over 3, or negative 2 pi over 3 to 0. You can go from anywhere you like to anywhere you like. But if you follow the same procedure every time, the same steps that I'm going to show you now, then it will be easy for you to graph all the trigonometric functions in this section. So watch how this is going to start. So the period, or the cycle begins at, if you remember from the lecture above, always starts at phi over omega, and I showed to you why. What is phi here over omega? We have it. It's pi over 3. So it starts there and ends at x equals phi over omega plus 2 pi over omega. Phi over omega is pi over 3 plus 2 pi. What's omega? Well, if you go back up here and notice this, omega is 3. If you compare the fractions, the denominator is 3. So here I combined them, 3 pi over 3, so that gives us pi. So I know now that the cycle is going to go from pi over 3 to pi. Note here, if you find pi minus pi over 3, if you subtract them, that will give 2 pi over 3. That's the length of the cycle, or the length of one period. So that, just to verify that we are on the right track, just to verify it. And now look what I'm going to do. I'm gonna just use the number line, and then after the number line, I'm gonna put this on the XY plane. So the number line, we agreed is gonna start at pi over 3, and this is gonna go all the way up to pi. Okay, so all the way up to pi. Remember, we need 5 points. I have 2 of them so far. To find the middle one, how do I find the middle one? Well, you just take pi plus the first one and the last one, and then we're gonna divide them together in a minute. Multiply by 3 to combine them. That gives me 4 pi over 3. If I divide this by 3, so by 2, sorry, divide this by 2, that becomes 4 pi over 3 times 1/2, which is 4 pi over 6. Of course, that can be reduced down to 2 pi over 3, but I'm gonna keep it as 4 pi over 6, and watch why we keep it as 4 pi over 6. I'm gonna get these 3 numbers to have the same denominator. So I'm gonna multiply this by 2 to make it 6, this by 2. Multiply by 6 and by 6. So that will give us 2 pi over 6. This will give us 6 pi over 6. Note the strategy here, or the trick. I see a 2 here, I see 4, and I see 6. Guess what's gonna be in the middle here? Just to save us work every time add and divide. So because that's 2 pi over 3, that would be 2 pi over 6. That's a 3 pi over 6. Then the one next to it is 4 pi over 6. The next one would be 5 pi over 6. And the last one is 6 pi over 6. Do you see the pattern? So I'm getting the pi over 6, multiples of pi over 6. So the first one was 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And it will work always like this. So now I'm gonna take these points and plot that on the XY plane. Okay, on the XY plane. The first one was pi over 3. So let's say pi over 3 is here. And this went all the way up to pi. Now the middle one was 4 pi over 6. So I'm gonna simplify it, 2 pi over 3. The one between them is 3 pi over 6. That's a pi over 2 if you reduce by 3. Then 5 pi over 6 goes here. 5 pi over 6. I found the 5 x coordinates of the points, and then I need to find their corresponding y values. So I'm going to show you step by step how to calculate this. One more time, the equation we had was 4 sine something. So let's write that down. 4 y equals 4 sine 3x minus pi. That was the given equation or function. So the first x value is pi over 3. So if I substitute this in, we get y equals 4 sine 3 times pi over 3 minus pi. What does that give us? 4 sine, cancel the 3's, pi minus pi 0. Sine 0 is 0. 0 times 4, 0. If I substitute the next value in, pi over 2, that will give me 4 sine 3 times pi over 2 minus pi. Let's subtract the ones inside the parentheses. 3 pi over 2 minus pi, that's pi over 2. And sine pi over 2 is 1. So 4 times 1, that's 4. The next one, x equals 2 pi over 3. Y would be 4 sine 3 times 2 pi over 3 minus pi. So these cancel. This is 0, so that's 0. X equals 5 pi over 6. So let's substitute that in. Y equals 4 sine 3 times 5 pi over 6 minus pi. By 3, 1, by 3, 2. So I get 4 sine 5 pi over 2 minus pi. So that would give us 3 pi over 2. And we know this is negative 1. So the answer is negative 4. One lost value, x equals pi. Y would be 4 sine 3 times pi, 3 pi minus pi. So 4 sine 2 pi. Sine 2 pi is 0. So 4 times 0, we're getting 0. So I got the 5 points their corresponding x and y values are given there. So now what we're going to do is we are going to plot these points on the graph. So the way I have it here, pi over 3 was 0, so there's going to be a 0 point here. The next one is 4, 1, 2, 3, and 4. So that's a 4. So that's going to be here. This one is 0, 1, 2, 3, 4, negative 4. So that's going to be here. And then the last one 0. So the graph is going to go up, down, and up. So this is similar to the actual y equals sine x graph, if you remember the other one. So what's the difference between the original sine x and this one? The first thing is this was shifted. You know, we shifted the graph pi over 3 units to the right side. If you shift the original sine x, because sine x started at 0, 0. And then there's a what we call vertical stretch of a factor by a factor of 4, because the original one went only up to 1. This one is went up all the way up to 4 because the amplitude was 4. These are the main things, you know, how the vertical stretch and translation to the right side. So students ask sometimes, can I do it in a different way using transformations? Yes, I'm going to call this as a second method. Second method to graph this. You can choose either one to solve the homework or on any test. Second method, using transformations. When we say transformations, means reflection, rotation, translation, all these are called transformations. So let's write the function again, 4 sine 3x minus pi. And I'm going to take it one step at a time. I'm going to just write down the steps. The first one, we graph y equals sine x, and we already should be familiar with this, over 0 to 2 pi. Then we start with the number outside, 4 sine x. What the 4 does, the 4 gives us a vertical stretch by a factor of 4. By a factor of 4. That's what the 4 means. The amplitude becomes bigger. Instead of 1, now it's 4. Now we graph this one, but instead of x, I'm gonna put 3x. So what actually I did, I replace x by 3x. And what does that do? So originally it's 1x. If there's an x, there's a horizontal compression. By a factor of 1/3. That's what this means. Vertical compression by a factor of 1/3. If it was 4 inside, by a factor of 1/4. If it was 5, by 1/5. Okay, so that's what we have. And then the next step is 4 sine 3x minus pi. 3x minus pi. So what we do here, if you like to see this, you can factor the 3 out. That gives us x minus pi over 3, as we did before. So then this tells us, this part here tells us what to do. This tells us it's a shift. We shift the graph. Whatever graph we obtain in step 3, we shifted now pi over 3 units to the right side. So these steps, they go in order. So whatever you do, you first do number 1, and then you take number 1 and apply number 2 to it. Number 3 get applied to 2, and number 4 get applied to number 3. It's not like we go back to the original function. So that's how it's done. And I'm gonna show you how can we get this? How can we graph this one? So I'm gonna apply all the 4 steps that I showed you above. So let's see how we apply them. I'm going to start by, and I'm gonna make this 2 pi, so that gives me enough space, and then maybe move the arrow up And we have 1, 2, 3, and 4. So 4 is here. 1, 2, 3, and 4. So that's -4. The origin is here. Good to label everything. So that's 0 to 2 pi. The middle is pi. The middle is pi over 2. And the middle is 3 pi over 2. I'm going to graph sine x first. This was a 1. This was 0, 0. Pi over 2, 1. Pi 0. And then the -1 here. And the last one here. So make sure to review the graph of sine x from previous section. So I went through this and then up there. So that's 3 pi over 2. That's the first step. Graph y equals sine 3x. Next one, vertical stretch by a factor of 4. So make the amplitude 4. So how do I make the amplitude 4? So this stays 0, 0 as is. This will go up to 4. This stays as is. This will go down to -4. So around here. And this stays the same. So now the next step is to sketch this down and up. So that's the next step. Step 2. So step 2 was in green. Step 3, replace x by 3x, a horizontal compression by a factor of 1/3. What does that mean by compression by 1/3? The y values are going to stay the same. I'm doing horizontal compression. Horizontal has to do with the x values. So what I'm going to do with these x values, you know, how many x values I have? I have 0 on the x-axis, pi over 2 that I've been using, pi, 3 pi over 2, and 2 pi. So look what I'm going to do to get the compression. We multiply each one by 1/3. Multiply each one by 1/3. So times 1/3 times 1/3. That's how we get it, the compression. 1/3 times 1/3. So this stays 0. This is pi over 6. This is pi over 3. This is the 3 cancel out, pi over 2. This is 2 pi over 3. So we got those 5 values of x. Those are the x values. So these are the x values. So I'm going to plot the new ones, 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3 on the same axes. Okay, on this axis here, x-axis. So let's see where each one is located. So I'm going to use the blue color for that. So 0, 0 stays the same. So I'm going to shade it with the blue color. Pi over 6 is 30 degrees. So pi over 6 here, the 3 point something. So it's going to be pi over 6. The next one is pi over 2, pi over 3. The next one, pi over 2, so the blue stuff. And then 2 pi over 3. So notice they're moving equal distances. So these 5 blue dots, they are at equal distances. Now for the first one, 0, 0 is going to stay the same. For pi over 6, basically what happened to the green dot right here, that green dot get compressed to the left side. So if you project it up, that's going to become here. So the green dot up there is going to become the blue one. Okay, I'm just focused on the green graph now, not the black one anymore. So then remember the pi, this pi became pi over 3. So it's going to go down to this. And the 3 pi over 2, like this point, became pi over 2. So pi over 2 -4. So it's somewhere here. And the last one, the 2 pi, became 2 pi over 3, 0. So the 5 blue dots, that's the new one. Up, down, and up. See how it was compressed? So it's kind of like we fixed it at the origin and we pushed it from right to left to compress it. So the blue one is the graph for y so far for sine 3x. Okay. One last step is I'm going to graph number 4 or part 4 here by shifting pi over 3 units to the right side. Pi over 3 units. So what do we get if we do pi over 3 units? So that means I'm adding pi over 3 to each x value. pi over 3. The y values, they stay the same, plus pi over, pi over 3. I'm adding pi over 3 to each set, plus pi over 3, plus pi over 3. So pi over 3 to the right side. So what we get, the 0 becomes pi over 3. If you add pi over 6 and pi over 3, it's pi over 2. Pi over 3 plus pi over 3, 2 pi over 3. Pi over 2 plus pi over 3, it's 5 pi over 6. Combine them by finding the common denominator. And the last one, 2 pi over 3 plus pi over 3, that's 3 pi over 3, which is pi. So now I'm going to shift the graph to these points. So the first point is pi over 3. So the 0, 0 is going to become pi over 3, which is this. That's pi over 3. That's the first point. That's where the graph is going to start. Then it's going to go to pi over 2. So this point here is going to become right above pi over 2. So it's there. The next point, 2 pi over 3. So what's the next point? The blue point. So this point is going to become here. The next point, which is this one, will be at 5 pi over 6. So you move equal distances. So 5 pi over 6 and negative 4. And the last blue point, which is this point, is going to be at pi. So here. So then the graph is going to again go up, down, this way. So this is the graph for y equals 4 sine 3x minus pi. 4 sine 3x minus pi. Now, if you look at this graph, this starts at pi over 3, ended at pi, and compare it to the graph we obtained in the previous method. So see, it went from pi over 3 to pi. But you might say, wait, the other one looks more skinnier or more vertical stretch. It just, here I give myself more space, and that's why. It's okay as long as you label the points the right way. You labeled on the axes, like the y-axis 4, negative 4, and you labeled the origin, the x and the y, and then put all these 5 points on the x-axis. That's what matters to us the most. So pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. And that's what we got here. So differences might graph it a little bit differently, like more compressed or more stretch or something, but the points are what matters to us. So if you compare this graph, the last one, see, it starts at pi over 3 comma 0, and then it went all the way up to pi over 2 comma 4, and then the next one is 2 pi over 3 0, and then it went down to 5 pi. So this is 5 pi over 6 negative 4, and then it went up to pi comma 0. So that's what this section is about. You can choose either method. Different students like different methods, so either one is fine to use. The first one, it depended on finding the beginning and the end of the graph, and then from there we use the phase shift helped us, and then I got the points on the number line, transferred them into the xy plane, and then I got their corresponding y values, and those y values helped me to plot the points and connect it. So since this has to do with sine function, so we expect the graph to look like a sine wave, like start somewhere, go up, down, up. So what I just did, I sketched a graph of that function over one period. So in this section, one more time, we needed to know the amplitude, the period, and the phase shift. Phase shift tells us if the graph is going to go to the right side or to the left side. And in the entire section, we assume that omega is always positive here. It could be negative, but in this section, we're just assuming it's positive. So that makes it easier. So if phi is positive, the graph will get shifted to the right. If phi is negative, the graph will get shifted to the left side. That's what this section is about.